Good day everyone, welcome back to our discussion on the topic differentiation. Today we will be treating quotient rule. Quotient rule is used for functions that are dividing themselves. It basically states that if y is equals to u over v, where u and v are some functions of s, then the y over the s is equals to v du minus u dv divided by v squared. Like I said earlier, it has to do with functions in fraction. Now we are going to take some example to explain quotient rule further. Our first example is from NECO 2005. It states that differentiate with respect to s the function y equals to 4x cubed plus 8 divided by 2x squared plus 3. Now in our solution, the first thing we are going to do is write down our equation, which is y equals to 4x cubed plus 8 divided by 2x cubed plus 3. Now recalling our quotient formula, the y over the s will be equal to v du minus u dv divided by v squared. Now our goal is to get each of the individual components of the formula. First, we are going to say let u be equals to 4x cubed plus 8. Then du will be equals to 12x squared. That is, when we differentiate 4x cubed plus 8, we are going to get 12x squared. And v will be equals to 2x squared plus 3. Differentiating v to get the v will be equals to 4s. Now at this point, we are going to substitute for v, du, u, dv, and v squared in our formula. Doing so, we get the y over the s will be equals to 2s squared plus 3 in bracket, which is v, times 12s squared, which is du, minus 4s cubed plus 8 in bracket, which is u, times 4s, which is dv, divided by 2s squared plus 3 in bracket square, which is dv square. Expanding our bracket in our numerator, we are left with 12s squared times 2s squared will give us 24s to the power of 4, plus 12s squared times 3 will give us 36s squared, minus 4s times 4s cubed will give us minus 16s to the power of 4, minus 4s times 8 will give us minus 32s, divided by 2s squared plus 3 in bracket squared. Now simplifying our numerator, 24s to the power of 4 minus 16s to the power of 4 will be left with 8s to the power of 4 plus 36s squared minus 32s divided by 2s squared plus 3 in bracket squared. Our next question is also from NECO. It states that differentiate the function 4s to the power of 4 plus s cubed minus 5 divided by 4s squared with respect to s, and we are given the options. Now in our solution, the first thing we are going to do is write out our function. Y will be equals to 4s to the power of 4 plus s cubed minus 5 divided by 4s squared. Since it's in fraction, we know we are going to be using quotient rule, and recalling our quotient rule formula, the y over the s will be equals to v du minus u dv divided by v squared. From our question, we know that u will be equals to 4s to the power of 4 plus s cubed minus 5, and differentiating that to get du will be equals to 16s to the power of 3 plus 3s squared. V will be equals to 4s squared, and dv will be equals to 8s. At this point, we are going to substitute for v, du, u, dv, and v squared. Doing so, it will be equals to 4s squared in brackets 16s to the power of 3 plus 3s squared minus in bracket 4s to the power of 4 plus s cubed minus 5 times 8s divided by 4s squared in bracket squared. Simplifying our numerator by expanding the bracket, which becomes 4s squared times 16s cubed with 64s to the power of 5 plus 4s squared times 3s squared will be 12s to the power of 4 minus 8s times 4s to the power of 4 will be minus 32s to the power of 5 minus 8s times s cubed will be minus 8s to the power of 4 minus 8s times minus 5 will be equals to plus 40s divided by 16s to the power of 4. At this point, we are going to collect like terms in our numerator. It will become 64s to the power of 5 minus 32s to the power of 5 plus 12s to the power of 4 minus 8s to the power of 4 plus 40s. Now subtracting and simplifying, it becomes 32x to the power of 5. That's 64x to the power of 5 minus 32x to the power of 5 will be equals to 32x to the power of 5 plus 12x to the power of 4 minus 8x to the power of 4 will give us 4x to the power of 4 plus 40x divided by 16x to the power of 4. At this point, we are going to split our numerator and divide each individual unit by 16x to the power of 4. Doing so, we are left with 32x to the power of 5 divided by 16x to the power of 4 plus 4x to the power of 4 divided by 16x to the power of 4 plus 40x divided by 16x to the power of 4. Simplifying, we are left with 32x to the power of 5 divided by 16x to the power of 4 will give us 2s plus 4x to the power of 4 divided by 16x to the power of 4 will give us 1 over 4 plus 40s divided by 16s to the power of 4. We are left with 5 divided by 2s to the power of 3. So our final answer is 2s plus 1 over 4 plus 5 divided by 2s to the power of 3. And the correct option is A. Our final example states that find the derivative of y with respect to s if y is equals to the square root of 1 plus s divided by 1 minus s. Now, applying chain rule, y equals to the square root of 1 plus s divided by 1 minus s is the same as y equals to 1 plus s divided by 1 minus s in bracket raised to the power of half. Let w be equals to 1 plus s divided by 1 minus s. Then y will be equals to w raised to the power of half. Now, applying chain rule formula which states that dy over the s is equals to dy over the w times the w over the s. We can easily get dy over the w using our general formula. Dy over the w will be equals to half w raised to the power of minus half. Next, we find the w over the s by applying quotient rule. W is equals to 1 plus s divided by 1 minus s. From quotient rule, u will be equals to 1 plus s and u will be equals to 1. V will be equals to 1 minus s and dv will be equals to minus 1. Substituting the value of u, du, v and dv in our quotient rule formula, the w over the s will be equals to v du minus u dv divided by v square, and the w over the s will be equals to 1 minus s in bracket times 1 minus 1 plus s in bracket times in bracket minus 1 divided by 1 minus s in bracket squared. Now, simplifying our numerator by expanding our bracket, 1 minus s in bracket times 1 will also give us 1 minus s minus 1 times minus in bracket 1 plus s will give us 1 plus s. Now, divided by 1 minus s raised to the power of 2. Now, simplifying our numerator, 1 minus s plus 1 plus s will be equal to 2 because minus s and plus s is going to cancel out. So we are left with 2 divided by 1 minus s in bracket squared. So our dw over the s is equal to 2 in bracket 1 minus s squared. Now, substituting for the y over the w and the dw over the s in our original chain rule formula, the y over the s will be equals to half w raised to the power of minus half times 2 divided by 1 minus s square. That is, the y over the w is half w raised to the power of minus half, and the w over the s is 2 divided by 1 minus s in bracket square. Simplifying further and remembering that w originally is equals to 1 plus s and 1 minus s, we are going to be substituting for w back in the equation. So we are left with dy over the s is equals to half in bracket 1 plus s divided by 1 minus s raised to the power of minus 1 over 2 times 2 divided by 1 minus s in bracket squared. Now, simplifying further by separating our bracket, we have 1 minus s in bracket is to the power of 1 over 2 divided by 1 plus s in bracket is to the power of 1 over 2. Our 2 in our numerator and our 2 in our denominator will cancel out, so it becomes times 1 divided by 1 minus s raised to the power of 2. Bringing our fractional indices down, that is bringing 1 minus s to the power of 1 over 2 downwards, it becomes 1 minus s in bracket 2 minus 1 over 2. That is, 2 will be minusing 1 over 2 since we are bringing 1 minus s to the power 1 over 2 downwards. So we are left with 1 divided by 2 minus 1 over 2 is equal to 3 over 2. So we are left with 1 divided by 1 plus s to the power of 1 over 2. Multiplying 1 minus s in bracket is to the power of 3 over 2. We have some questions for you to try your hands on at home. The answer to these questions are found in our Hidden Facts Further Mathematics textbook. You can easily get the hard copy, or if you are interested in the soft copy, you can get that at the website on the corner of the screen. Thank you.